Okay, so sorry about the little delay here. Um, so I think we worked through pretty much a really large portion of kind of this last topic, which was instrumental variables on Tuesday. So we'll kind of look at some other examples today. We'll talk about some additional things related to this. And then I think we'll probably have a little bit of time. I might jump into kind of some exam review if we have a little bit of time towards the end of class. So right now, kind of only thing left is we've got that problem set, which I have set to be what? Due a week from today, right? So at the end of the day, um, just a kind of reminder, today's like the last day of new material. Tuesday's class, we won't have class. All right, so I'm going to post a recording. I'm going to record it tomorrow. Should have it posted tomorrow by the end of the day. It'll basically just going some review problems, through some review problems from primarily practice exam B. Right? This was the one that I said we'll start today. I don't have an answer key up for it. We'll work through most of it today in that video. And then next Thursday's class is just a day for review. Okay. And then our final exam is what? I'll try to do something. I think it's Thursday from 12:40 to 2:40. Am I getting that time correct? We can double check myself because it should be, excuse me, in the syllabus here. We'll be in kind of this room, so location should be pretty easy to find. Yep, so 12:40 to 2:40 that final exam week. Okay. I'll have office hours as usual next week on Monday and Wednesday, even though we don't have class Tuesday. So we're finishing up that problem set. Those are good times to kind of come in, make sure you're kind of getting as many available points as you can there. And then I'll mention something here at the end of class after we kind of review what we have left in instrumental variables. So we left off thinking about how we're going to perform these two-stage least squares regressions. We looked a little bit at this in Stata, but essentially we've got a bunch of bias that we can have. So measurement bias, omitted variable bias, simultaneous causality. So one way we can get around this is using this kind of instrumental variable approach, where I think of a good instrument, right? So before we talk about what makes a good instrument, we said the process is going to be whatever X variable I'm interested in the effect of on Y, right? So I've got it in the slides here, but we'll just kind of write it out again. There we go. So my initial thing that I want is an unbiased estimate for the effect of X on Y. Okay. What I'm going to do is try to think of this instrument Z, right? And we'll talk about the conditions for a good instrument in a second. But if it's a good instrument, I'm going to try to predict this X variable that I'm interested in the effect of. Right? I'm going to try to predict it using whatever this instrument is. Okay. Now, the actual Y values will contain some error. Right? What I'll do is use this, what we call first stage regression. I'm then going to come up with predicted values. And we can see how we do this in Stata, but really, it would just be plugging in whatever that coefficient estimate is, different values for this instrument to come up with our predicted value for X. Once we have those predicted values for that X variable, we're then going to go back to like our original regression, and we're going to try to predict Y, but using those predicted values of X. If we've used a good instrument, our new estimate for beta 1 should be unbiased, right? Whereas before, when we weren't instrumenting for it, they had omitted variable bias, potentially had measurement error bias. So this is going to be kind of our two-step process. So what are the conditions we had for a good instrument? So the first is we said it simply needs to be correlated with the X variable we're interested in. So this needs to be something other than 0. Right? So whatever instrument we're using, it needs to be related to that X variable. Now, the second condition that we had was that I said here, technically, it's that that instrument is uncorrelated with anything in our error term. So once we've controlled for X, the only thing left in our error term is anything that influences Y other than that X variable we're interested in. If that's the case, right, we've got a good instrument. Now, I said one way you can think of this is it's basically, is that instrument unrelated to Y? Okay. Now, that's not quite right, because how can I ensure that that instrument is less likely to be related to my error term? Well, what happens to what's in that error if I just start adding in additional controls? My error, or if I have more controls, my prediction should be more accurate, right? So that error term, I'm removing things from my error. If I add in more controls, making it less likely my instrument is going to be correlated with that error term. Okay. So those were kind of our two conditions. Last class, we really focused on kind of this first condition. We kind of a hand waved over the second. I said, well, I could look for the covariance, right? This simple command. We do that in Stata and look at what that is. But what's another way I can see whether or not two variables are related? When I run this first stage, if the coefficient that tells me the relationship between X and Z, if I can reject the null, what I'm really saying is there is an effect of that instrument on X. So from our first stage regression, we're really looking at the statistical significance of that coefficient on our instrument from that first stage. Okay. Now, one thing we also talked about last class, but I think we'll go into a little bit more in detail today. I said, what's another statistic we could look at from that first stage that would tell us if our instrument is good at predicting X? It's another statistic that tells us if we have a good predictor of our dependent variable. Our R squared or our adjusted R squared. Okay. So there's going to be a statistic that comes from our first stage, which essentially compares what our adjusted R squared would be using that instrument versus not. That's going to produce us a F statistic, right? So we know that if we include this instrument, more variables will always increase our R squared. But does it do that at a statistically significant level? Our general rule of thumb, if that F statistic is greater than 10, then we essentially could reject the null. The null is that there was no effect on X of using that instrument. Okay. So Stata will kind of do that behind the scenes for us. Really, all we need to do is look to see, is that F statistic greater than 10? Okay. So this is kind of where we left off. Any questions? We're diving into some more like examples here. Okay. So there we go. The next thing we'll kind of think about today, and we talked through, another way I could calculate this is if I took the covariance of Y with my instrument divided by the covariance of X with my instrument, if I haven't included additional controls, this would actually give me my unbiased coefficient estimator that removed that omitted variable bias. It won't quite be the same thing if I add in controls, and in practice, we would want to include as many controls as possible to make sure that that correlation, it's not in the slides here. Oh, sorry. Yeah. We want to make sure that correlation of the instrument with our error term is equal to 0. Right? So in practice, we know we're going to want to include some instruments. So this won't quite work for us. But if I gave you a simple linear regression where we don't have any additional controls, I don't actually have to do this two-step process. I could actually just calculate the covariances, and I would see the same estimate as if I did this two-stage process. So we'll look at that in some data, some applications here in a second, Stata to see if that's the case. But we can add in controls, right? So here I'm just kind of saying W. W could be not just one control, it could be 5, 6, 7, 8. But if we include these controls, we need to make sure we're doing so in both our first stage and our second stage regression, right? So the controls need to be the same in both of these regressions in order for us to kind of have this unbiased estimate of beta 1, which was the effect of X on Y. Okay. So that's where we kind of left off, right? So here we'll just focus on that first condition, which we mentioned last class, which was basically, is that X variable correlated with my instrument, right? Is the covariance something other than 0? Well, if I run my first stage and that statistical significance is pretty low, right? Maybe I can reject at the 90%, but not 95 or 99. That would be evidence that I kind of have a weak instrument. So that statistical significance of our coefficient from the first stage tells us whether or not this is a strong or weak instrument. And we'll look at some examples here in a second. And then really that F statistic, if it's greater than 10, that's good, but the higher it is, the more, statistically significant it is. That's another piece of evidence that would be, this is a strong instrument. Okay. Now, we can check that second condition, which is that our instrument is unrelated to anything in Y, anything in that error term that we haven't controlled for. Now, the problem is we don't have at least for the sake of this class, a good test. So we kind of have to rely on our intuition. So this is where maybe on the exam, I'm going to ask you justify why you believe this is a good instrument. And it would have to be something about you don't think that it's going to be correlated with that error term. Okay. Excuse me. So here it's going to be, we're going to analyze some different examples and just think about why that instrument might be good or not in terms of meeting that second condition. Now, you can always look at kind of the covariance of Y with Z. That'll be somewhat, Y with Z. That'll be some evidence, but it's not perfect because we're also not adding in those additional controls. Right? So here we also have another way of kind of testing for, and then we'll jump into some more data files, and then we'll kind of work through some practice exam problems. But we have this test that basically says, do I need an instrument? So the whole reason we need an instrument is because there was going to be things that maybe impacted both X and Y, like an omitted variable. Right? So if we run the regression, we know with this omitted variable, our estimate will be biased. How do I know if there's things that are impacting both X and Y? It's going to be something we need. We can't just want to rely on intuition. We have this test, right? So we're going to start out assuming that there is no endogeneity concerns, that there's nothing that we think that impacts both of these variables, X and Y. That's good. That's what we want. We're going to assume that's true. If we can reject that, what we're really saying is there are these other factors that we're not controlling for that would impact both these variables. We need an instrument. So when we're running this endogeneity test, this Durbin-Hausman test, essentially what we don't want to do, we don't actually want to reject here. Because if we fail to reject, that's saying we don't need an instrument. If we reject, now we have to think of, okay, this was an endogenous variable. I have to think of a good instrument. Right? It's easier to not need one, right? And so what we're going to do to run this Durbin-Hausman test is I'll run my initial, ignore this for a second, 90 regressions. I'm trying to predict Y with X, and I have some additional controls. So what I'm going to do is run that first stage where I try to predict X using this instrument, and then I'm going to save my errors from that first stage. So this is going to be when I'm trying to predict X using my instrument, anything else that would be explaining X other than my instrument, that's going to be captured in my error term. If that, everything else that's in my error term, well, that's controlling this instrument. That would be anything else that would influence both X and Y. Only if those errors, when I'm running them in my second stage, if they're correlated with Y, that means it was all the error that I didn't remove from using this instrument. So that's going to tell me if this is related to Y, I've got an issue. I had things that were both impacting X, and now if I can reject the null for the coefficient on those errors, that's saying there was also things that weren't in that instrument that were also impacting Y. That weren't my estimate that were impacting X, but also impacting Y. That's bad, right? We want it, that's part of our problem. We have these omitted variables that are impacting both variables. And so we want to fail to reject that coefficient is anything other than 0. So what is this going to look like, right? So let's go to kind of stata here. And let's think, we worked through kind of this medical expense example last class. Let's look at, talked about parental education. Oh, is there anything I want to do here? Well, we kind of can revisit some of what we talked about last class. And then I've got additional examples. So this is where I said, if you didn't already do this on your device, this just installs all those free data sets. And then we can kind of open up this wage data. So I'm going to run this naive regression, right? This is the one where I think that there's likely things that could impact both education and wages other than these controls, right? So maybe this is something like, what was the income of my family? That might impact both whether or not I'm pursuing more education, but then also more opportunities for me to work for my dad and be in a high position that I don't actually deserve, right? So could be things in here that I haven't included, like income, a bunch of other omitted variables that would explain changes in both education and wages. So I think there's a bias here. So I need to think about a good instrument. And we said last class, well, maybe a good instrument is my father's education, right? Because his education, a company doesn't care about that in terms of, are they going to pay me more? So it shouldn't be related to why. So my father's education shouldn't be related to my own wages. However, if my father had a degree, it's probably more likely I'm going to end up kind of attending college and have a degree as well. So there it meets the first condition, which is my father's education is likely correlated with my own. And then it's my father's education is likely uncorrelated with my wage in any other aspect other than that it influences my own education. So it's everything we've controlled for here, we've now controlled for my father's education. It would have to be anything, my own education. It would have to be anything other than my own education that would explain wages. I can't think of a good reason here. Maybe, I don't know, maybe my father's education makes it more likely I'm in a geographical region that does pay higher wages. So there might be some kind of intuition that you could come up with that would violate that second condition, but we don't have a way to test for that. That's kind of where we have to rely on what we know about these variables. Seems like it's probably good though. Right? So we go through, we had that shortcut, which is just kind of using the IV regress command. Now what it does is it runs both the first and second stage, but if I don't add in this comma first, it won't show me the first stage. So if I'm looking at stata output, which I might give you something like this on the exam, I've got my first stage, which would essentially be I'm trying to predict education using my father's education, and then my other controls. So notice my dependent variable here would be my own education, and I've controlled for experience, age, married, and I use the instrument of father's education. So once I have these first stage results, the two things I can check are the statistical significance of my instrument, which here is my instrument of father's education statistically significant. Highly. So my instrument is correlated with X. It is correlated, my father's education is correlated with my own. Now, what's a second indicator, very strong indicator that this is a good instrument in terms of that first condition? My F statistic is not just greater than 10, it's greater than 100, right? So this is a very strong instrument in terms of meeting that first criteria. What I would then do is use these coefficient estimates and for every person go through and predict what their education should be. Not what their actual education is, but given these variables, what their predicted education would be. I then save those predictions and I would include them here. So in the stata output, it doesn't really identify that that I'm not using the actual education variable. I'm actually using the predicted education. You can't really see that in stata, but that's what it's doing, okay? And then it's also including our additional controls. So here it looks like now the effective education is not 72. Once we've used this instrument and removed a bunch of that omitted variable bias, it's almost twice as large now. Okay. So this kind of goes to show you can, there might be a lot of bias in some of these estimates. Okay. Now, the manual approach would be I run that first stage. So this is where I think last class I did some of this for us as well. But we're going to regress, right? We're going to try to predict X using our instrument and all of our additional controls. We're then going to save. Oh, sorry. We're going to use those predicted values for X and include them in our second stage regression, where we're now trying to get back to the original thing we wanted, which was what's the effect of education on wages? So from my second stage, I should now, if I've done this correctly, get the same estimate as Stata did when it was doing everything behind the scenes. So I'll run these lines of code. Sure enough, I get 142. Right? Just a different way of doing the same thing. Okay. Any questions on that before we keep moving? Once again, kind of reviewing an example we looked at last class, but I'm going to add some things here in a second. Now, I also said if we don't include additional controls, so now I'm getting a coefficient estimate of 100.69. So let's think about why. If I don't include these additional controls, what might be violated now? So if I don't have these controls, there's going to be more things in my error term. So potentially now my instrument is correlated with the error, which I didn't want. So now I'm getting a different coefficient estimate because it might be that I don't have as strong of an instrument. Because I don't have these additional controls, it might be more likely that covariance between my instrument and the errors is now not zero. Okay. However, we'll ignore that for a second and just assume that is not the case. If I looked at those covariances between, here I can kind of add these in, right? So this was my covariance between Y, my wages, and that instrument Z, father's education. This was the covariance between X and my instrument, my own education and my father's education. What I would then do, well, here, to get that same coefficient of 100, I would simply take, looks like I spelled this wrong, but hopefully we could figure out what that was. I would take the covariance of Y with my instrument Z, divided by the covariance of X with my instrument Z, and I kind of showed you the mathematical proof last class. We said we don't have to reproduce that. I should get the exact same value as I did right here. All right. So just kind of supporting that, what I was telling you is true. Right? And then I could also kind of use that first stage. We kind of already had that before. We talked through these criteria, why they might be met. So the next thing that we want to look at is, do I actually even need this instrument? So if I have something that's impacting both X and Y, and I haven't controlled for it, I need this instrument. Or is there things that are endogenous that are impacting both X and impacting Y? So we said that the kind of process that we'll use is we're going to run our first stage regression, which, remember, that was we were trying to predict X with our instrument Z and all of our additional controls. So here I'm trying to predict education with my father's education and these additional controls. In Stata, we have a nice, easy way to kind of come up with those predictions by using that predict command. Now, we didn't want the predicted values for education here. We're not running that instrumental variable regression. We're testing to see, do we need an instrument? So instead of saving the actual predicted X values, we save the errors that we were making in that first stage. So I use that kind of resid command onto the end of predict, and this will predict my errors from that first stage. Oh, sorry. I'm going to have to drop that variable because I forgot a line of code. I forgot to run a line of code. So sorry about that. So we're going to run that first stage regression, save our residuals or our errors, predict errors. We're then going to go back to our original regression where we wanted to predict wage using education or X variable, include the additional controls, but also include the predicted error terms from our first stage. If these are statistically significant, that tells me there was things that were impacting X that also are going to have a relationship or are impacting Y. So if I can reject that the coefficient on these predicted errors is something other than 0, I need to include an instrument. So I run this regression. I look at that predicted error, p-value 0. I definitely can reject the null. The errors from my first stage are also explaining some of the variation in Y, which must means there was some things that were impacting X that I didn't have controls for that are also impacting Y. That means I need an instrument. Okay. So that would be our kind of test for whether or not we need an instrument, or this Durbin, or did I scroll too far? There we go. Our Durbin-Hausman test. Okay. Any questions on this before I keep moving here? Okay. So we kind of already went through this. Father's education. So we'll kind of actually got another example here, and just for the sake of time, because we're going to run out of time, I think, here today. I'm probably a little bit long-winded, but we'll go through another example. Okay. So let's say I kind of have a similar thing, but I now want to predict wages using somebody's IQ. Okay. Now the problem is IQ tests are not perfect, right? So I'm going to have some measurement error that's in that IQ variable. So I know that if I have measurement error, potentially that's going to create bias, right? If that measurement error is correlated with my X variable, so maybe people who are more intelligent, the IQ test is going to be more reliable. People on the lower end, maybe it kind of, isn't as accurate. So if that's the case, we're going back to our measurement error, we said that's going to cause a bias in our estimates. I can actually resolve that as well. So what I'll do is I think about, here's my naive regression where I don't use an instrument. I get that the effect of IQ is very significant, and it's 8.4. Now, for every 1 point increase in IQ, I would expect that the person's average wage, and I think it's like monthly wages, goes up by $8.4. Maybe this was weekly wages. I think it was weekly wages. That makes a little bit more sense, right? So I then think about, okay, what would a good instrument be? So what if there was a kind of instrument that was going to be correlated with IQ? So I'm going to use another test of intelligence. So this KWW, I think it's the knowledge of the working world test. It's some measure of the person's aptitude or their intellectual ability. So if IQ and this other test, they're both trying to measure intellectual ability, then they'll definitely be correlated. My first stage is my first condition, is likely to be met. And I can use my first stage results to test this. Is this knowledge of the working world test? This is where it gets a little confusing. Do you think this other test would be correlated with Y? So if someone scores higher on this other test that measures intelligence, do you think that would predict their changes in their wages as well? Probably. But it's not that we need the covariance of the instrument with Y to be 0. It's that we need the covariance of that instrument and the error term to be 0. So once I've controlled for IQ, now this other test shouldn't explain any more of the variation in wages, right? Anything else other than this previous measure IQ of intellectual ability, now that knowledge of the working world test would have to be correlated with anything other than the person's intellectual ability that would predict wages. I can't think of an explanation there. Maybe, I can't think of an explanation, right? So it seems like that second condition would be met as well. So I'll run my first stage, save kind of those predicted values. I'll include them into my second stage. Should get the same results if I run these manually as if I use that IV regress command, right? So I'll run these two regressions. I see from my first stage, is this a good instrument? Well, what do I need to look at to see if it's a good instrument? The easiest one is that F statistic greater than 10? It's 73 here. Looks like probably a good instrument. Now, if I looked at that instrument, its statistical significance in predicting my variable I'm interested in, or this knowledge of the working world test, is it correlated with the IQ test? Very strongly, right? P-value of 0, test statistic of 15. So it looks like that first condition is supported from our first stage results. Okay. If I then look at my second stage results, notice what is the coefficient on this predicted value of IQ? Now, it's now what, 16.7? From our naive regression, it was only 8.4. Once again, we have an example where the effect size more than doubled once we eliminated this omitted variable bias. Now, we've looked at examples right now where the coefficient gets higher. That doesn't have to be the case. We could be eliminating bias in the other direction, in which case it might go from being positive to being negative. just making sure we know that is a possibility, right? So that's good. I think that I know this instrumental variable stuff seems difficult, but once we get to the exam questions, you'll kind of see, you know, if I ask you if the first condition is met, you're looking at the statistical significance of your instrument from the first stage and the F statistic. You know, that won't be too crazy, right? So we could look at whether or not the second condition is met. So that would be if I regress wage, well, ideally I could, if I had the errors, I would look at the covariance of my instrument with those errors. But if I run a regression where I'm trying to predict wage, controlling for IQ, and then look at the effect of this knowledge of the working world test, that should tell me if this isn't good at predicting wage, conditioned on IQ, that covariance, right, is likely equal to 0. So I run this regression, and I can see here, okay, once I control for wage, this knowledge of the working world test is correlated with Y. Probably is the case that this isn't a great instrument for that second condition, because the instrument should not be correlated with my Y variable. When I say correlated, right, that coefficient estimate tells me if there's a causal relationship between that instrument and Y. Now, what can I do to maybe make it more likely this is a good instrument? I can remove things from the error term. So what would I add in here? I would add in my additional controls. Because I did include those in the regression, now I'm saying, is that knowledge of the working world test correlated with Y, but holding constant, not just the X variable I was interested in, but all the controls I had as well. So now when we run this regression, we can kind of see here, okay, it's still statistically significant. I mean, the test statistic's a little bit lower, so we're getting closer to having that, but not quite. Right? So, you know, I can't come up with the explanation, but maybe this knowledge of the working world test, maybe, I don't know, maybe there is something about like the geographical region that I'm in that I'm not controlling for that would impact both of those things. But, you know, we have an indicator here, might not be perfect. But putting that aside, do I even need this instrument, right? So I think there's things that are impacting IQ and wage, but like maybe there's not. Maybe I don't have any omitted variables, or maybe this measurement error, actually isn't correlated with IQ. So I might not even have to worry about it. What I would do, I can run my regression here. So this was just to kind of add in, our Durbin-Wu-Hausmann test to see, is there endogeneity? Are there things that impact both my X variable and my Y variable? Do I need an instrument? So similar process. I run my first stage, but now I save my predicted errors. So the residuals that came from that first stage, I then include those into my second stage regression, but I'm not using the predicted value of IQ now, I'm using the actual IQ values. So I'll run this regression, and what I see here is those residuals are statistically significant. So that tells me there's something in that error that explains X that also explains Y. I don't want that. And that's the whole part of the problem, right? So I need an instrument here. If I can reject the null of those error terms once I include them into my regression, I'm saying I'm rejecting that there's no effect. So there is an effect. That means there's something impacting both X and Y. I need an instrument. So another way you could do this, makes it a lot easier, is after you run your instrumental variable regression, if you use this SStat and Dodge, it actually gives me a test for this. So it's a little bit more complicated than what we were doing, just looking at the coefficient on our predicted errors. It's basically like not technically going to be coming from a student t-distribution. So it gives you some other test statistic in the p-value, but it would result in kind of the same outcome if we did it how we just did. I'm kind of looking at that coefficient on the error, or predicted error term, I should say. So just wanted to kind of mention, like, there is an additional way to do this. You know, when I'm grading the fifth problem set, which should all be graded now, right? You should see your kind of updated score in Canvas. I don't necessarily care, but I know, like, you guys are, some of these problem sets, it's stuff that I'd have to revisit and remind myself exactly what these statistics are that you're mentioning, which means it's probably outside the scope of this class, which I went on a rant. Did I go on the rant to you guys already? Yeah. So like, it's okay to use it, but like, you want to use it to improve your understanding, right? So just be careful, right? I'm not going to expect you to kind of use this because we're not talking about these kind of chi-square distributions, right? But just to kind of mention like the next level, we do have ways of doing this where we don't always have to do it manually. There's a kind of these built-in kind of tools and data that we could use, okay? Any questions on that? Okay, so I'm going to do one more example, and I'm going to try to give you the types of questions that you would see on the exam. So it's kind of like we're doing a review here. It's almost like I could put these into a practice exam and do the same thing. So I have this file, and now I realize, oh, actually, I had it last class. Let's go up here, run my global command, and then we'll come back down here. I have this NCAA tournament file, which, you know, it's not too far in the distant past, so we can kind of think about this. So I had this naive regression, and I was thinking about when there's universities, and here I want to think about what is the impact of getting more applications on the average, did I do SAT score here or math SAT score of incoming freshmen? So if I was like a university, and this is, you know, universities are companies at the end of the day, you could end up working for a university in their data department. Why might I want to encourage more people to apply to my university? Because I could then be more selective. So if I can be more selective, what's going to happen to the incoming ACT of my freshman class? It's going to go up. The only problem is, what universities likely get more applications? Really good one. Harvard gets tons every year. IU gets tons. Not, you know, oh, what school I want to pick at? Wabash College probably doesn't get near as many, right? So there's likely going to be things that are correlated with the number of applications the university is getting. That's also going to be correlated with the quality of the applicant. I have things that are impacting X and Y. I probably need an instrument. Okay. Now I've controlled for like how many undergraduates they already have. So I'm trying to control for the size. So I'm not like comparing Wabash to IU, right? I'm more so like controlling for the enrollment. Currently, I'm like comparing IU to Purdue to, you know, I don't know, kind of similar institutions. So I love institutional size. And then I had whether or not they've made the tournament the prior year. I'll kind of mention why in a second. So I had this idea, and we'll see if it works, right? But my idea was like, okay, I want to predict this. What's a good instrument? So when I fill out a bracket, there are schools sometimes in there that I didn't know existed, right? Some of these, so what is essentially making that NCAA tournament where millions of people fill out brackets, and even if you're not a basketball fan, people are somewhat, it makes the headlines, it's essentially free advertising. It makes more people know that my university exists. So what am I more likely to get? I mean, I didn't, let me try to think of one. Like, I don't know, if I'm from Northern Indiana, I might not really even know about Indiana State. Or, you know, I know of the major universities, but I didn't really know that there's a IU affiliate in, well, not technical, the one in Fort Wayne is now a Purdue affiliate. There used to be IU or IPFW, I think they changed their name now, but that's the idea, right? These schools make the tournament, now people know they exist, they might apply there as well. So I thought, okay, if they make it into the tournament, they're one of those 64 teams, it's likely going to increase their applications. But making it into the tournament, I mean, should that predict, other than its effect on applications, whether or not my school has a higher SAT? Currently, no, right? My basketball team makes a tournament, I still have the average. So it seems like it might be a good instrument. So I've controlled for these other, you know, have these additional controls. And I want to look at that first stage result. So here I look at my first and second stage. So first of all, I thought I was going to have a real banger of an example here, but why is it like almost not really a good instrument in terms of that post criterion? My F statistic is barely above 10, right? I mean, so technically it meets that general rule of thumb, but not great, right? Now, the other piece that really leads me to think maybe that first condition isn't met is what's the statistical significance on the instrument from that first stage? Nowhere close to my conventional cutoffs. So this probably isn't a great instrument, but even if it's not perfect, it might be eliminating some omitted variable bias. So we'll kind of just act like it is for a second. So I then kind of think about, okay, excuse me. What did I have here? So I could also test for whether or not, well, here, where's my second stage results before I do that? So I get an estimate on, oh, where is it at? My predicted applications, it's 0.0011 compared to my naive regression, which I guess I didn't even run that. We could do that real quick. So here was my naive regression. Applications 0.004. Okay, so it did change my estimate. Even though this isn't a perfect instrument, it did eliminate some of that omitted variable bias. Okay. Now, the second thing we could look at is my second condition met? Okay. So my second condition is my instrument controlling for the X variable and my other controls? Is it correlated with Y? It shouldn't be, right? So run this regression. Looks like it's not correlated with Y. So my second condition looks like it's pretty strongly met. I mean, I have a p-value of 0.6 here. But I might be a little bit concerned about that because even though it met one of them, it didn't meet, even though for that first condition, I have one statistic that supports it was met, one of them doesn't, right? So I liked this example actually, because when I look at those first stage results, I have one piece of evidence that it does meet that criteria. I have another piece of evidence that it doesn't. That can happen, right? When my instrument is kind of on the cutoff of being strong, like good or bad, I shouldn't say good or bad, but strong or weak, those two things might not always point in the same direction, which all the previous examples that we looked at, they did, okay? All right, so we'll kind of come back down here. Any questions before we keep moving? Then we have just one more thing with this example we'll look at. So do I even need an instrument here? I think logically there's probably things that impact both applications and my average SAT score, but maybe not, right? So I run that first stage, predicting, what do I have here? Oh, never mind. I didn't do a Durbin-Hausman test here, but we could. So let's just, let's do that real quick, as long as we're here. So if I wanted to do this Durbin-Hausman test, what I do is I take my, where is it at? So I'll copy and paste this down here. So I run my first stage regression where I was trying to predict the number of applications on whether or not they made the tournament, right? And then going to predict my errors from that first stage, right? Kind of using that resid command. And then I'm going to go, and I forgot regress here, right? And then I'm going to kind of run my second stage. Right? Trying to predict with all these controls, but I'm going to include my errors. Okay. So in doing this, when I look at that predicted error term, that would mean, are there things that were correlated with X that are also correlated with Y if I can reject the null, right? Because if I can't reject, what it's really saying is all of the things that I wasn't able to have data on that impacted X, they have no effect on Y. That means that there's nothing endogenous or nothing that is impacting both X and Y. Here, I failed to reject the null. So do I even need an instrument here? No. If I fail to reject, what that's saying is there's nothing that would explain the variation in X that also explains the variation Y. There's nothing that's correlated with both of them that I haven't already controlled for. Okay? So here with our Durbin-Hausman test, this would be an indicator because I failed to reject, I don't need an instrument. So maybe write that down. When we're doing this test for endogeneity, if I reject that coefficient on my predicted error term, I'm rejecting that there's no effect, right? We always start out assuming the coefficient is zero. If I can reject that it's something, and we reject that it's zero, it's something other than zero, that means I have an endogeneity concern. I need an instrument. If I fail to reject that coefficient is anything other than zero, I don't have endogeneity concerns. I don't even need an instrument in this regression. Okay? Or I don't need to use an instrumental variable approach would be the more appropriate way to say this. Okay. Any other questions on this example before we kind of move on here a little bit? Okay. All right. So that really does it for all of our new material. So we don't want this. I accidentally opened up the midterm practice, so that won't help us. So let's go back here. Oh, it didn't update my OneDrive because I forgot there's an update for us. So we'll go to files. We'll kind of come down here. Got my final exam practice. I said we're going to work through B as much as possible in class. I haven't given you the answer key yet. I want to kind of work through some of this today and then in that review video. And then I'll kind of get that answer key posted, incentivizing you if you want to study early to kind of make sure you're kind of looking at that review video. Okay. So we're going to come down here just to kind of keep the class cohesive today and try to think about instruments. Okay. So where are we at here? I think this is the first one. Yeah. So let's say I had this example, right? And I want to try to predict traffic fatalities using alcohol consumption. Okay. I think that, if the alcohol consumption of a state or county goes up, there's more likely to be accidents. There's more likely to be traffic fatalities. That seems reasonable. The only problem is there might be some things that are correlated with both alcohol consumption and whether or not there's traffic fatalities, right? Maybe, I don't know, people of, we could be real prejudiced, or we could just think of a random example, like maybe people with higher income tend to drink less, but they're also more responsible drivers. So, well, they're drinking less and there's fewer traffic fatalities, but it's because their income is higher or something like that, right? So we're concerned with omitted variable bias. And here I've got controls for, what was even percent per capita income. I've got controls for the population, but maybe there's things other than that that matter. So I'm going to use this instrument of beer tax, right, or an alcohol tax. So is this a good instrument? So I think the first question we have here, give 2 reasons from the output of why this might be a good instrument. Well, first of all, from my first stage, I can only address whether or not that first condition is met. We wrote it down earlier. What is our first condition? So we could think through this writing out our variables. So that first condition was that there's a correlation between X and our instrument, or in our example, between alcohol consumption and, I said beer tax here, but you can think about it as like any tax on alcohol. So you don't try to come up with some weird explanation to me like, well, I don't, people don't drink just beer, and so the tax might not. So let's just think about an alcohol tax, okay? So what am I looking at for my first stage? Is that F statistic greater than 10? And is that coefficient associated with my instrument statistically significant? Or can I reject the null? Okay. And then our second condition, right? So typically this is going to be referred to, and it gets kind of weird here, but this is like our endogeneity condition, that something is with our instrument is correlated with X. And then our exogeneity condition, so it means it's something outside of the model, would be that covariance of our instrument with the errors when we were trying to predict Y is equal to 0. And I forgot here, it's not equal to, right? There is a correlation. So here I'm thinking about, okay, is there something in my error term when I was trying to predict traffic fatalities that I wasn't controlling for that could impact traffic fatalities, but also impact the alcohol tax of a county or state? I mean, there could be, right? It's kind of hard to come up with an explanation as to what that do. I mean, governments don't typically make policies, I wouldn't think, based off of just traffic fatalities. I mean, maybe speed limits, but would speed limits be correlated with alcohol tax? I doubt, right? I can't think of something that might be impacting both. And so it's likely that this condition is going to be met. Now, we didn't have any statistical ways to kind of really test this yet. That would be kind of outside the scope of this class, would be the next step. But we can test this first condition. So when I'm looking at that output on the practice exam, here's my first stage results. If I asked you in this question, what are 2 reasons, and I probably would say like 2 statistical reasons for why not this is a good instrument in terms of that first condition, it's because the F statistic is greater than 10, it's 32. And the coefficient on my instrument of beer tax, okay, well, what levels could I say this is a good instrument? Well, what levels can I reject that the null is 0 for that instrument? Only at the 90 and 95% level, not quite the 99. So it is a good instrument, it's just not the strongest, right? Ideally, I would want this p-value to be 0 to have kind of real strong support, okay? Any questions on that? Before we keep moving here. So let's say I did something else, right? Which is I don't include any additional controls. And this is, I think this one should be hopefully an easy one if I gave you a question like this on the exam. So I have this instrumental variable regression. And what am I asking here? So below are the second stage results, covariance of beer tax and traffic fatalities. I want you to tell me, second part of the question is down here. What is the covariance between beer tax and alcohol consumption? Okay. So I've got the same setup, but I'm now thinking about, I was trying to predict traffic fatalities using alcohol consumption. We said I could do this 2-stage least squares, but what should be true is that coefficient estimate I see if I run an instrumental variable approach, it should be the covariance of my y variable with z over the covariance of my x variable with z. So for us, that's going to be the covariance. And here, what was our instrument? We were using tax. I'm just kind of abbreviating. So it should be the correlation of traffic fatalities with this alcohol tax over the covariance of alcohol consumption with our instrument, which was alcohol tax. So in that practice exam, I gave you what the coefficient estimate was if you did instrumental variables. So you're going to know this. I think if I look back there, and we'll switch back over, but just so I have the value, I think this was like negative 765. I'm rounding a little bit, but about that. Right? I also gave you a covariance matrix that told you the covariance between beer tax or alcohol tax and traffic fatalities. So we'll see where we could get this from the table in a second, but this was 22.4. If I ask you for the covariance of that instrument alcohol tax with alcohol consumption, I have one equation, one unknown. I should be able to do this algebra, right? So I'd have what? That covariance between alcohol consumption and that alcohol tax is equal to what? 765 over 22.4, right? So anytime I give you 2 pieces of information here, you could always back out the third. So where did these values come from, just to kind of help you see this? So our second stage result, which should be our unbiased estimate, was, I'm sorry, I forgot the negative sign. It was negative 765. Now the covariance between beer tax and traffic fatalities is 22.4. Okay. So the only thing I didn't have was that covariance between our alcohol or our beer tax and alcohol consumption. So I could have instead gave you a covariance matrix between this alcohol tax and alcohol consumption, and then you could have backed out what the covariance was of traffic fatalities and alcohol tax. Right? So, I could do that either way. So don't always think when I give you this covariance matrix, it might not necessarily be that the covariance I'm giving you. I could give you this one. I could give you this one. And then if you see that coefficient from that second stage result, you could always kind of back out whichever one I can give you. Any questions on this before I keep moving? And once again, forgot my negative sign out here, but okay. Any questions on this idea? Okay. All right. So just to kind of round out this discussion, I might go through this a little bit quick and kind of revisit it when I post this video. So here's another one. Excuse me, and this might be something that I'd ask you to do on the exam. So I give you these two variables. I want you to predict whether or not someone gets cancer based off of their cigarette use. Okay. So this I'm trying to show you, some really good instruments are usually things that the government does that we as individuals don't have any control over. So if I use like taxes, cigarette taxes, that's going to be correlated with X, cigarette use. If I put a tax on something that does what to the price? Hopefully as econ majors, you know, increases the price, which means I should use more or less. Less, right? As the price goes up, quantity goes down, right? So this tax is going to influence my cigarette use. And then would that cigarette tax be correlated with whether or not I get cancer? So this would have to be that the government is making tax decisions based off of the current cancer rates. Not even the current cancer rates. It would have to be things that are correlated with you specifically getting cancer. I can't think of anything there, right? So it's probably a good instrument. I might ask you to write out your first and second stage. So this is where, if you're thinking about this first and second stage, you would always have the kind of general form that you could write out for yourself, which is I first want to try to predict that X variable I was interested in using my instrument. So for us, I'm trying to predict cigarette use because our original question was, how is cancer impacted by cigarette use? So this was my Y variable. This was my X variable. My instrument that I was using was cigarette tax. So this would be writing out that first stage. Now, my second stage, I've got to be careful because yes, it's going to be my Y variable. However, what am I, sorry. Let me see that, there we go. However, what am I going to use in that second stage? I'm not going to use my instrument. I'm still using that X variable, but I'm using what? The predicted value of that X variable. If you are concerned with notation or something like that in the exam, I would also accept if you put in here like predicted whatever that X variable is, right? So, I mean, that's all that hat means when we're coming up with these predictions. That was another way of using notation. But if you wrote something out like this, indicating to me that you don't just use cigarette use in that second stage, you use the predicted value that came from your first stage. Right? So I might ask you to kind of write out these first and second stages as opposed to like just giving them to you. Okay. Any questions there? Okay. So we've got what, 10 minutes left. Here I probably would do something a little bit less like this. Try to direct. I kept the practice exam here a little bit more broad. But what are the two conditions? So you would need, I kind of already talked through this, you need cigarette taxes to be correlated with cigarette use. Hopefully as econ majors, you could explain to me why that first condition is met, right? That taxes increase prices and likely decrease cigarette use. Seems like a good instrument in terms of my instrument will be correlated with X. The second part, I'd probably be pretty lenient on the grading if I asked it like this, because you'd have to say, there's nothing else that cigarette taxes would not explain cancer, whether or not someone gets cancer, other than through cigarettes taxes effect on cigarette use. It would have to be that cigarette taxes change something else about individuals' behaviors that makes it more likely to get cancer. So what might be an example? This is a bit bizarre, but maybe, right? I think about it actually this way. Think about instead we wanted to do marijuana use instead of cigarettes, and we have like a marijuana tax, or make it illegal is our instrument, right? If I make it illegal, it's likely people use less. What might be something that making marijuana illegal would impact that I'm not controlling for that could also then change cancer rates or whether or not somebody with cancer? If I make one drug illegal, what might people do? Use other drugs? I think Indiana is probably a good example. I would go out on a limb. I am not a doctor, but I see all these like Delta whatevers. Right? I can't imagine that there's got to be so much artificial shit in those things that like that's probably going to cause you more likely to get cancer than actually using marijuana. So if I make marijuana legal, if that's my instrument, well, what would that also likely impact? My use of these other products, which would then also impact cancer. It's likely that second condition wouldn't be met. Right? So that would be a good explanation as to why this wouldn't be a valid instrument in terms of that second condition. Okay, but that's where we don't have any statistical support that we can give, at least in terms of what we're talking about in this class. That would have to be something that's more intuition based. And if you just simply told me you don't think there's any other individual behaviors that would be impacted by the cigarette tax, that would also help me in predicting cancer rates, that would be a valid answer as well. But I use this example because I knew we would probably go through it in class, and I think it's interesting to think about what really makes a good instrument. Okay. So before we get out of here today, I've got two things that I want to mention that you'll care about. Right. So the first is, if I can get this to go here. So we've got this quiz today. I think I have it hopefully set to be the end of class. Nope, I was going to do it earlier, so we'll change the due date here. So this is the final, kind of last kind of quiz. I think I looked back at the syllabus. If I'm doing this incorrectly, I believe that for this class, I drop your two lowest in-class quizzes at the end of the semester. So once we have this one turned in, I'll update Canvas so that it automatically shows you what your grade would be if we drop, with those two lowest dropped. So I'll get that changed when I get back to my office later today. I don't even think I had an access code in this one today, so you should be able to get in more than okay. Just want to kind of get this out there. So for us today, just for the sake of time, because there's some other things I want to mention, just respond with anything here. If we have a little bit of time. I mean, basically, what are we looking for? We're looking for whether or not the F statistic is greater than 10 to meet that first condition. So that doesn't make sense. There's statistical significance of this cigarette tax. So that's really the one that we're going to be looking at here. But as long as you respond to both of these questions, you'll get full points for the day, right? Now, what I would do is after maybe go back and review those. In fact, when I record that video, maybe these are the first two questions I'll work through, just so you kind of have me working through this as to why the correct answers are what they are. But just for the sake of time, got 6 minutes left. There's some other things I want to mention. Yeah. Okay. So yeah, any answer here, you'll get full credit. I think it's set so it's not that way, but when I get back to my office, I'll kind of update it. Okay. And just getting it submitted here before 2:00 p.m. Right. That's what will kind of get you that full credit. Okay. So I'll kind of include those in that recording I used to replace Tuesday's class, because I probably would have saved this to be on Tuesday's class next week. But I'll work through these in that video. Okay. Is that clear what I'm saying there? Okay. One other thing, right? So you've got that final problem set, should be the only other thing that's kind of due after today's class. I'm also going to post this 6th quiz. Okay. Now you might be like, that son of a bitch is going to give us a quiz and expect us to study for it and whatever. You didn't give me practice problems. Okay, well, let's just hold off for a second because I'm trying to be friendly here. So I've got it set to be due at the end of next, 27th would be the end of the day, Monday, right? So this shouldn't take you long, but I would really appreciate if you take a little bit of time when you sit down and take this and kind of put some actual time into responding here. So I gave you a lot of different questions. Some of this, the quicker you get it in, the more it's, if you get it in by Monday, which is when it's due, I'm going to look at some of these results and then cater what we do in class on Thursday to kind of make sure I'm focusing on the things that people find the most difficult. So there's just questions about the class, more of the structure, what you found helpful, what you didn't find helpful, some fill in the, open response. This is almost like those OCQs, but these are questions I actually care about. That actually mean a little bit more to me, and I can kind of get the course kind of updated or see kind of what you found to be beneficial, what you didn't. Now, if you scroll all the way down here, after question 10, the last few here, right, are actually kind of opinion-based, but then I also have some that are related to kind of the use of AI in this class. So I'm just generally interested in how much you use that. I'm not going to look at any one individual's responses here. Right? I'm going to look at all of them in this concept. I'll download them and they won't have names attached to them. And I don't really I don't care if you use it or not. I do care. I'm not going to penalize you or evaluate your grades. Go back and look at it. I just want to know how much you're using it, where you found it the most useful or helpful in learning in this class. So I try to be pretty specific in that, like not just help you getting the correct answers, but like actually kind of assist you in the learning process. And then whether or not you think that the use of it actually impacted your AI, like your performance, right? Because if it didn't help you learn and it just helped you get the right answers, maybe you didn't do as well in the exam. Looking at the midterm exam scores and problem set scores from this semester compared to previous ones, I think it probably didn't help your exam performance. If I think a lot of you were just using it to get the answers. And so I'm just generally interested in some of your thoughts and opinions about the course and of what you did to kind of just help me be better moving forward. So if you please put some time into this, I would appreciate it. But ultimately, as long as you complete it, the 6th quiz, you will get a 20 out of 20, right? So, as long as you get on and complete it by the end of the day, Monday, easy points, okay? So this is where I'm not going to post something up on Canvas, so it's good that you were here, right? There's a 6th quiz, shouldn't be too bad, okay? Any other questions for me? So I will get tomorrow posted something just with more of the details, just so there is an announcement on Canvas in terms of, the day, location, time, things like that, kind of the format. That video I'll be posting, I'm recording it tomorrow, so I'll get it posted up by the end of the day tomorrow to replace Tuesday's class, and then we'll just have a review on that Thursday class next week. Once again, office hours next Monday and Wednesday. I'll actually have office hours the Monday of finals week. I know that my office hours will be busy because I have 2 300-person sections of B251. So I will post some additional office hours that I'm going to have on Wednesday that are going to be less traffic because they're just going to be for you guys. I don't know exactly when they'll be yet. Probably something like 2 to 4 in the afternoon. That way you don't have to come in the morning and compete with the B251 students. If you want to, you could still come by Monday morning. It's just, there might be a line, right? So any other questions before I let you guys get out of here? All right. So enjoy a little 5 weekend. Not too much, but I want to see you back here next week.